Hi, welcome to my class. Today I'm going to explain message authentication. So, what is message authentication? In this class, I am going to explain what is message authentication, how this message authentication happens, or how sender and receiver uses this message authentication concept for sharing the messages, right? So, message authentication mainly it involves using one secret key, K, and it receives another information message M, right? So message M, it takes message authentication, takes message M and one secret key K, and which produces fixed length message, fixed length output, right? Fixed length block of output or data, right? So fixed length data is outputted from message authentication function because message authentication using one particular function and assume that particular function as C, right? This is message authentication function. This message authentication function receives one input is message, and another input is key, and which produces fixed length output. We call it as message authentication code, or we simply call it as cryptographic checksum. That message is called cryptographic cryptographic checksum, right? Cryptographic checksum. So that fixed length message is called as either cryptographic checksum or message authentication code. So after generating message authentication code from message authentication function by the sender, what he does is he concatenates or he appends message authentication code with original message, right? Original message. So this particular information is transmitted to receiver, right? So the general concept is this receiver. Okay, na? So after receiving receiver, we must verify whether the sender is authorized or not, and is there any modification happened or any integrity happened or any updation happened on this particular message, or any attacker attacked the communication channel and changed the message, right? Because Mac he cannot change, because this Mac code or Mac code is generated by the Mac function with the help of secret key K, right? This secret key K is known to only sender and receiver. This K, secret key K, known, secret key K is known to only sender and receiver, right? Only sender and receiver. So no opponent or no third party, no cracker or no criminal, no attacker can change the MAC, right? So there may be a chance of changing message because we are sending plain message or plain text along with the MAC code to the receiver. But how receiver checks? Generally, after receiving this particular message by the receiver along with this MAC code, his duty is he must again generate MAC code from this. Again, he must generate message authentication code from the received message by using the same function, right? With the same key, because this key is also available at receiver. That key should be maintained by both sender and receiver. So whatever the procedure that sender used to generate MAC code, the same procedure receiver uses to generate MAC code. After generating MAC code, he also received MAC code, right? So the received MAC code and generated MAC code both are compared. Received MAC code and generated MAC code both are compared. If both are equal, if both are equal, if both are equal, means the received MAC code and generated MAC code by the receiver are equal, then receiver feels that sender is authorized. Receiver feels that sender is authorized. This is first assumption, authorized. And second assumption is message is not updated. Message is not updated. If message is updated by the criminal or attacker, then he gets false MAC, right? Because finally he is comparing received MAC with the generated MAC. If message is updated, then he need to generate MAC code from the MAC function with the help of key K. If this message is updated, means he get MAC code, but that MAC code is not going to match with the received MAC, then he immediately feels that this message is updated by the third party, right? So these two. So sender is authorized from this particular one. He confirms that sender is authorized. Only authorized sender sends that message because this key is known to authorized sender and receiver, and the message is not updated because MAC generated MAC code at the receiver end, and the message which is received from the sender, if both are matched. So from this particular comparison, he concludes these two. Even any sequence number is attached to this particular MAC code, he can verify. Only the receiver can verify because the receiver knows so which sequence number he has to get, right? So this is about the general concept. Then I'll show you how block diagram wise we can show this particular concept. But here what happens is in the first simplest, this is the simplest scenario. Here sender is sending message along with the MAC code to the receiver, right? Sender is sending message along with plain text along with the MAC code to receiver. There may be a chance of altering this particular message by the opponent. Anyway, if message is altered, you cannot alter the MAC code. So once after receiving this particular information by the receiver, right? After receiving this information by the receiver can cross check whether this message is updated or not. Okay, na? Just with this particular operation. Okay, na? So this is the simple concept. I'll show you the simple concept and updated concept also. In updated concept, this is not going to happen because the message is also going to encrypt, or the total message after concatenation is going to encrypt. Okay, na? I'll show you. In the first scenario, I'm going to draw very simplest diagram. I'm going to draw very simplest diagram. Just whatever I have explained, just I'll show you diagrammatically. Okay, diagrammatically I'll show you. After that, I'll show you the updated versions because here we are sending plain text message. But if you simply change the concept, the same concept, but instead of sending the plain text, we can also encrypt the message. From this hypertext, we can generate the MAC code, or sometimes what we can do is from the MAC code, and once after generating MAC code, we can also after concatenating, we can also encrypt it, right? So there are two different concepts after this. One is encrypting the message, and that particular encrypted message is uh, going to be involved in MAC calculation, or MAC and the message authentication code after combining, we can also encrypt it. But initially, I'm going to show you the simple concept, right? Simple concept. Let us assume message is there, right? Let us assume message is there at sender. Message is there at sender, and he wants to convey that particular message to the receiver, right? That particular message to the receiver. Now this is the message, right? This is the message here. Okay, now here what the sender is doing is sender immediately sends this message to MAC function. I told you already, MAC function is C, right? MAC function. This MAC function takes another input as secret key K, right? So from this, he generates MAC code, right? So this MAC code is going to be combined with the original message M. This is the simplest form. Original message M. So he is concatenating MAC code with the original message M. That particular information is transmitted via communication channel or any internet or any other communication channel. That particular message may be transmitted to receiver, right? This is sender part. This is sender. Suppose if you give the name of sender as A, then this is sender part. This is receiver part. So receiver is receiving message as well as MAC code. How can we represent MAC code? Because MAC code is generated. MAC code is generated by the MAC function C, which takes the input as key is one input, message is another input, right? So this is the MAC code. But what he is going to do is he again receiver must generate MAC code from the received message. MAC code from the received message with the help of same key, because whatever the procedure sender used, the same procedure must be used by the receiver to verify whether the received message is correct or not, right? So this MAC code, and he is already received MAC code, right? He is already received MAC code. These two are compared each other, right? These two are compared each other. If the comparison result is yes, if the comparison result is yes, then I told you now 2 points, important points. He feels that sender is authorized. From the authorized sender only he received the message, because the key used at sender and key used at receiver is known to only sender and receiver only, right? Only authorized sender can use this key, and only authorized receiver can use this key, right? Because there should be a mutual understanding between sender and receiver, or mutual communication, mutual agreement. We call it as mutual agreement. Mutual agreement is there between sender and receiver for sharing the messages. So after receiving the message and MAC code, the receiver generates MAC code again using the same procedure as used by the sender, and he compares the generated MAC code at the receiver end with the received MAC code by the receiver, right? If these two are equal, then receiver feels that sender is authorized, and the message is not altered by the any other third party or opponent, right? So this is the simple scenario. This is the simple scenario. Here we are sending a message, plain message along with the MAC code, right? Plain message along with the MAC code. Here authentication is provided. Authentication is provided, but there is no confidentiality, because message is plain text. Message is plain text. That plain text is transmitted via, this is communication channel. This is any established communication channel, or sometimes they may use internet. They may use internet for sharing the messages, right? So this is simple scenario, and I'll show you updated scenarios. In first updated scenario, instead of generating MAC code from the plain text, that particular message is encrypted by one particular key, right? And that encrypted message is going to be inputted to MAC function. That MAC function generates MAC code, and encrypted message and the MAC code, generated MAC code, are appended at the receiver end. The receiver also does the same thing for verification, right? I'll show you that particular configuration, and third one also, right? So in the second configuration, what sender is going to do and how the receiver parallelly performs at the receiving end, right? I'll show you that particular diagram also. Okay, na? So first, what we need to do is in second configuration. In the second configuration, sender sender generates the message and is going to encrypt it first using encrypt it first by using encryption algorithm with the help of another key. Let us assume that key is K2. That key is K2, right? So this encrypted message is going to be inputted to MAC function, right? That encrypted message is going to be inputted to MAC function. MAC function takes the K1 help. Here two keys are involved now. K1 help, and which generates MAC code, that encrypted message and MAC code are concatenated each other like this, right? Okay, na? So encrypted message is directly inputted to concatenation function. That encrypted message is going to be inputted to MAC function. That MAC function generates MAC code. That MAC code and the encrypted message are concatenated each other, right? So at the receiving end, generally, this is the receiver part, right? This is the receiver part. So receiver receives encrypted message is one. Encrypted message is one. The how can we represent symbolically? Encryption algorithm is E. That is, encryption algorithm is E. Encryption algorithm takes message as input, and another one is K2, right? Message as input, another one is K2. So this is the representation of received message. How can we represent key? This key is generated by using message authentication function C. This message authentication function receives one input as K1 and another input is encrypted message, right? What is that encrypted message? E of K2 comma M. E of K2 comma M, right? This is encrypted message. So this is encrypted message. On that particular encrypted message, with the help of K1, we are applying MAC function, right? So this is the encrypted message at sender side. So these two informations are received by the receiver, right? Then what receiver performs now? What receiver performs? Generally, this message authentication code is generated from encrypted message, right? Anyway, encrypted message is available here. So this particular encrypted message is inputted to MAC function. Okay, now this MAC function is using A1 as key. So from this he generates MAC code, right? So this MAC code and received MAC code, both are compared, right? Because received MAC code is C of K1 comma E of K2 comma M. So this E of K2 comma M is given as input to MAC function. This also becomes same. So C of K1 E and input is E of K2 comma M, right? E of K2 comma M, right? Now, what he does is, so immediately after generating MAC code, he also received MAC code from the sender. So immediately compares these two. If both are equal, then receiver feels that received message is correct. But the received message is there in encrypted format. Then he must restore the original message, right? He must restore the original message. How we can restore the original message? Just by conducting decryption, right? Just by conducting decryption, we can restore the original message, right? We can restore original message by conducting decryption. How we can conduct decryption? We uses decryption algorithm. We uses decryption algorithm. Generally, for encrypting the data, sender used K2. Here, receiver should also use K2 to decrypt the data. From this decryption, we can restore the original message. Yeah, right. So this portion is receiver portion. So from this is receiver, right? This portion is receiver portion, right? So if sender is A, then receiver is B. So in this particular configuration, I hope you understood, right? So from message, we encrypted message by using key, another key, that key, we are assuming that the key is K2, that encrypted message is given as input to MAC function. MAC function generates MAC code like this. This is the MAC code, and this is encrypted message. These two are combined each other, and through internet or communication channel, this message is transmitted to receiver. Now receiver receives encrypted message and key which is generated from encrypted message. Now key is generated from encrypted message, right? This MAC code is generated from encrypted message. Anyway, encrypted message is available at receiver. He immediately generates MAC code from the encrypted message. Already he is having encrypted message, encrypted MAC code from the encrypted message, right? So these two are compared each other by the receiver. If these two are equal, then receiver feels that message is not updated, because he cannot update, because even opponent cannot update the message also, because that message is encrypted using only the secret key which is known to sender and receiver. But anyway, he generates a MAC code, and he also cross checks whether received MAC code and generated MAC code both are equal or not. If both are equal, yes, receive message is not updated by the opponent. Then what he does? He immediately decrypt the message by using the key which is used at the sender side for encryption, right? So K2 here also uses K2 for restoring the message. Okay, na? So here message authentication provided, authentication and confidentiality both are provided, because earlier model there was no confidentiality because plain text is as easily sent to the receiver. But here we are not sending plain text to this particular configuration. Ciphertext we are sending. So that's why authentication is tied with ciphertext. Authentication is here, both authentication, this particular configuration is producing or providing authentication and confidentiality. Both are provided. Confidentiality is also provided because receiver and receiver are also using secret key, right? And for decrypting secret key, receiver is using. And but this particular authentication is tied with ciphertext, because MAC code is generated from the ciphertext, right? Tied with ciphertext. So this is one alternate for providing confidentiality. Okay, na? And another alternate is, first we generate MAC code from the message. After concatenating, we are going to encrypt the concatenated information. I will show you that diagram also, right? I'll show you that diagram also. I hope you understood this. I'll show you that diagram also. But in that diagram, the little variation is there. Instead of encrypting the message first, we are going to generate the MAC code from the message as first version, first configuration, right? But we are not going to send that particular message as first version or first configuration. We are going to encrypt the entire concatenated information, right? So that is the another alternate for providing confidentiality, right? Another alternate for providing confidentiality. Okay, then that also I will show you now. Right? Very simple diagram. Okay, this is message generated by the sender. He wants to send this particular message to receiver. with the confidentiality, right? Anyway, authentication is provided because only authorized user can use the key for generating MAC code, right? Key for generating MAC code. So here he uses that using K or K1. Okay, na? Then from this he generates MAC code. This MAC code and message are concatenated each other. But after concatenation, we are going to encrypt it. After concatenation, we are going to encrypt the total message. I'll show you symbolical representation, right? This encryption is conducted by using key creative, right? And this entire information is transmitted to the receiver, right? This entire information is transmitted to the receiver. So this is the total message. This is the total message, and this message is containing encrypted message with MAC code. Encrypted message with MAC code. I'll write symbolically. This one is C of key is K1 and message M, right? C is K1, message is M. And here this message is concatenated. How can we write it? M concatenated with C of K1 comma M, right? C of K1 comma M. This is the message finalized up to this. But what we are doing, we are encrypting the data by using K2. Then this particular final result is from the encryption, what we can do is encryption algorithm is E, encryption algorithm is E. This encryption algorithm receiving key as K2 and message is M concatenated MAC code. M concatenated MAC code. This is the message finalized at sender side. That message is encrypted. This message is encrypted by using another key K2. So that message is forwarded to this. So this particular message containing this. This particular message containing this, right? Then what he can do is, first he must decrypt the message, right? Because the total message is there in encrypted format. Then he must decrypt it. Decryption algorithm. He is using decryption algorithm D, and with the help of same key, whatever the key the sender used for encrypting, he must use the same key for decrypting. So after decrypting, what he can restore is, after decrypting, he restores original message and message code, that is key of K1 comma M, right? After decrypting, we can restore this entire content, M and CK of M. The same story as a first method. The same story as a first method. What he can do, he generates MAC code from the message with the help of the key which is used by the sender, right? And he compares this MAC code with the received MAC code, right? He compares MAC code with the received MAC code. If both are same, if both are same, then he feels the same, like sender is authorized, okay, and that message is generated by the authorized sender, and that message is not altered by the receiver, third party, right? Third party. So like this, the assumptions are made by the receiver. So this is the second alternate. First one is original one. We are not going to encrypt anything, just accept generating MAC code. That MAC code and the original message are concatenated like this. This portion is belonging to first scenario. Just we are extra adding encryption to first scenario, right? And that encryption is and that encryption algorithm encrypts the entire concatenated message with the message authentication code or cryptographic checksum. That information is finalized like this, and this information is forwarded to the receiver. This is the receiver portion, right? After receiving this message, that message is there in encrypted format. We must decrypt by using decryption algorithm. We must decrypt by decryption algorithm. After decryption, he restores the message and checksum, right? Message and checksum are separated. From this message, we must cross verify whether message is updated or not. So from this, again, he applies MAC function by using K1. He generates MAC code as the MAC code generated at sender side, and he compares MAC code with the received MAC code after decryption, right? If these two are matched, then receiver feels that sender is authorized and that message is not altered by the third party. So like this, message authentication code helps both the sender and receiver for sharing the messages. So first configuration, second configuration, and third configuration are very, very important. So through those configurations, first we say that message authentication, there is only authentication, there is no confidentiality in first configuration. But second and third configurations are producing confidentiality because receiver is also using secret key. But Second configuration is producing confidentiality and authentication, but authentication tied with ciphertext, because after encrypting we are generating code, right? But third configuration is also producing both authentication and confidentiality, but here authentication tied with plain text, right? Authentication tied with plain text because MAC code is generated from the message, original message. But in second configuration, MAC code generated from the encrypted message. That's why authentication tied with ciphertext in second configuration. Here authentication tied with original message, means plain text in third configuration, right? So in this way, sender and receiver uses message authentication code or message authentication concept or function for sharing the message in secure manner. Thank you for watching my video.